Switch case in Python. First, we'll observe the concept of switch case in Java and C++. Then we'll understand how to do this in Python using the if-elif-else ladder. This is a naive solution, so we then learn how to do it using dictionaries, lambdas with dictionaries, and using classes. One of my favorite constructs in C++ is the switch case. It just makes perfect sense to me, as if it's the only way to do this. When you need to check multiple conditions one by one, a switch case is a great tool. If case 1 is true, do this and break out of the switch case. Else, if case 2 is true, do that and break out. And so on. Let's study a Java switch case to find out which day of the week it is. This is a function week that takes an integer as an argument and returns a string. This has a switch case that switches on the integer argument. If this is 0, the function returns Sunday and then breaks out of the switch case. It does not check the rest of the cases. If I is 1, the function returns Monday and then breaks out. And so on until case 6 for Saturday. And if the value of I matches none of the values for the available cases, the function returns invalid day of week. This is the default case. How does this work? If we make a call to the week function with the argument 3 and then print it out, day 3 of week is Wednesday. Looks like a convenient way to implement multiple value checks. But what about Python? Python has no switch cases, just like it has no goto statements. But we can find a way to simulate it. Let's build an if-elif-else ladder. Week is 3. Now, if week is 0, day is Sunday. If it is 1, day is Monday, and so on. In Python, there's no such thing as an else if, but we have the elif keyword for this. If none of the conditions is true, the statement under the else is executed and day is invalid day of week. Now when we print day, it gives us Wednesday. But this solution is quite unsophisticated and naive. Let's see what we can do about that. We can build a dictionary to hold values for cases, which are the keys here. Define a function week on the variable I. It has a dictionary called switcher. This has day numbers as keys and day names as their values. This function returns a key for whatever integer value it is. It does this with the get method. We tell it what to print out when it cannot find the requested key. Now, week of 2 gives us Tuesday, week of 0 gives us Sunday, week of 7 gives us invalid day of week, and so does week of 4.5. Isn't this much better than the if-elif-else ladder? In the last example, we told the get method what to print if the key did not exist in the dictionary. We can also use a lambda expression for this. This code defines two functions, 0 and 1. These return the strings 0 and 1. We have a function indirect that takes an integer and has a switcher dictionary. The key 0 has the value 0, 1 has the value 1, and 2 has the lambda expression that takes no arguments and prints out 2. We make a call to the get method on this and pass the integer and a lambda expression to it. We store this call in the variable func and then return a call to it so the lambda for invalid can be called. Now indirect of 4 is invalid, indirect of 2 is 2, indirect of 1 is 1, and indirect of 0.5 is again invalid. We can also do this using classes. class switcher has four methods: indirect, number 0, number 1, and number 2. Indirect decides which method to call and then returns a call to it. The other three return the values 0, 1, and 2. Then we declare an object S of class switcher. S.indirect of 2 is 2. S.indirect of 4 is invalid. And S.number 1 is 1. You should come back to this once we've discussed classes in detail. So while Python does not directly support the concept of switch cases, we can still build one in it.